Well, howdy there, Internet students. Mr. Hermanson again. Today we're going to start finding volumes. And we're going to concentrate on prisms and cylinders because they're very similar in how you find the volume. Okay. Why don't you go ahead and do this first problem, and you can check back and see if you got your answer right. So you should have found that each of them holds 64 of those little yellow cubes. And my idea on how I would explain it is that if you talk about one layer of each of these and then multiply by the number of layers, so one layer on this one is 2 times 4, which is 8 on the bottom layer. And then we're going to multiply, there's going to be 8 layers. The height is the number of layers. So 8 times 8. On this one, there's 32 in the bottom layer, and then the height is 2, so 32 times 2. In this one, there is 4 times 4, 16 in the bottom layer, and it's 4 high, so 16 times 4. So that's the way we're going to find volume of prisms and cylinders. We're going to figure out how many are in the bottom layer, which is the area of the base. And I think we're just going to use big B for that one. And then the number of layers, which is the same as the height. So this is our basic formula for finding the volume of prisms and cylinders. It's the area of the base times the height. Okay, now because of this dude named Cavalieri, he figured out that the volume would be the same whether you tilted the object or not. It's still the area of the base because the base is still the same size, and then times the height. Okay. And then, all right, so let's concentrate on that. I think they want us to use this side over here on this first problem. The base is this 5 by 6 side, so let's do that. 6 times 5 would be the area of the base, 30 square millimeters. And then we just have to multiply that by 12. So we're going to get 360 square millimeters for that one. All right, you want to try one? You guys probably caught that Mr. Hermanson mistake there, that this should be a 3 because we're adding up how many cubes are in each object. So let's move on to the next page. Again, we're just going to try and find the base. Now the base, when you're talking about a prism, there's always 2 of the same when we consider it the base. So this side would be the base. Since it's a right triangle, 15 is the height. So we're going to take 8 times 15 times a half for a triangle, and that's equal to 60. So the area of the base is 60. And then we're going to multiply that 60 times 22. And that equals 1,320 cubic inches. All right, you try the next triangle, see if you got this. All right, I think 150 is about right for that one. Okay, now the volume of the cylinder is exactly the same. It's just that the way we find the area of the base is the area formula for a circle, pi r squared, and then we just multiply that by the height. So base times height, base area times height is pi r squared times height, which is pi times 6 squared times 14, which is 36 times 14, which is 504 pi in terms of pi. All right, I think we're ready for you to try one here. Now remember, by Cavalieri's principle, it's still going to be the same. You're going to take the base area times the height. In this case, the height is 3. I'm thinking you probably got about 3 pi for that one. All right, finding the volume of a composite. So we have a hole in this. So what we're going to do is we're going to find the volume of the cylinder, and then we're going to subtract the volume of the cylinder that makes up the size of the hole. So that gives us I hope you just skipped ahead through all that computer glitching stuff. So, so what we're going to do here is we're going to take this cylinder that has a diameter of 20. So we're going to take the area of the base, which would be 10 squared times pi times the height, which is 18. And we're going to subtract the hole, which has a diameter of 14, so a radius of 7 squared pi times 18. We'll leave it in terms of pi. So we get 1800 pi minus 882 pi. And in terms of pi, we can go ahead and subtract those, and that gives us 918 pi. All right, it says the approximate value, so you could probably round that if you wished. Okay, so go ahead and try the next problem, and you can check and see if you got that one right. Okay, so to the nearest cubic inch, it looks like about 5,089. What I did is I took half of a circle, semicircle right there, for the top part of that little thing. Now this side is the base, since there's 2 equal sides like that. And so you do the 36 plus half of that. And then the height is the 10th dimension. All right. So I think that finishes it up for today. I was thinking, wouldn't it be awesome if somebody paid you, like for each math problem you do, $1? Oh, wait a minute. I think they do. It's just a future installment.